All right, let's talk about something that's happening right now, in the shadows of the AI revolution. We're going to pull back the curtain on research sabotage. It's a secret war being fought over the very code and data that's going to define our future. And today, we're going to break down exactly how it works. So just think about this for a second. Picture an AI that's built for something incredibly important, like detecting cancer or driving a car safely. Now, what if, buried deep inside its programming, someone intentionally planted a seed of failure? A tiny hidden command to make the absolute worst decision at the most critical moment. This isn't some sci-fi plot. It's the very real danger we're diving into today. And if you're thinking this is just some far-off theory, well, think again. According to the report we're looking at, in 68% of research organizations, the sophistication of these attacks is already outpacing their ability to defend against them. That's right, the fight has already started, and for a majority of places, the defenses are already falling behind. So first up, we've got to look at the core threat itself. We're talking about how the very engine of AI development is being targeted to poison innovation before it even gets off the ground. You know, this isn't just about some lone hacker trying to break through a firewall. The source material is really clear on this, calling it a multi-vector threat. And what that means is that attacks are coming from all angles at once, from the technology, from the people, from the processes. It's a coordinated assault on the entire system. Okay, so to really get a grip on this threat, we have to understand the weapons being used. So let's pop open the attacker's toolkit and take a look at the technical blueprints they're using to sabotage an AI. The most fundamental tool in the box is something called data poisoning. It's pretty straightforward, actually. An AI is only as smart as the data it learns from. So what happens if you feed it poison? You deliberately corrupt that training data, you teach the AI all the wrong lessons right from the start, basically guaranteeing it's going to fail when it really counts.
Here's a super simple technique to show you how this works. It's called label flipping. In a good, clean dataset, the AI is shown a picture of a cat and is told, hey, this is a cat. Simple. But in a poisoned dataset, an attacker just flips the label. They show the AI that exact same cat photo, but this time they tell it, this is a dog. You do that enough times, and the AI's entire understanding of reality just gets completely warped.
And this is the part that is just wild, the massive outsized impact of this. The report shows that poisoning less than 5% of the training data can cause a catastrophic 40% drop in the model's performance. Think about that. A tiny, almost undetectable change creates a huge, devastating failure. But it gets even sneakier. Attackers don't just go after the data. They go after the AI's brain itself. This is called model architecture subversion, and it's a much stealthier kind of attack. The goal here is to change the model's fundamental structure, to secretly put a limit on how smart it can ever actually get. A perfect example of this is something called a weight initialization attack. Now, that sounds complicated, but think of it like this. It's like giving a brilliant student a faulty calculator right before a huge math test. They learn all the right methods, they study hard, but their starting tools are rigged from the get-go to give them the wrong answers. The research shows this can cripple a model's final accuracy by up to 25%, and the scariest part, it's completely invisible during the early training phases. Okay, so now that we know the tools, where are the weak spots? Where do these attackers actually get in? This next part is all about the cracks in the foundation of the whole AI development pipeline. Well, a lot of the time, these entry points are hiding in plain sight. They're the digital doors and windows of the lab, API endpoints connecting to the outside world, simple file upload systems, even the layers that are supposed to clean and organize the data. Every single one of them is a potential way in for saboteurs. And here's a number that, wow, it should really make everyone pause for a second. The research found that cloud-based AI development platforms, the ones that are becoming the industry standard, have a supply chain attack surface that is 3.4 times larger than the old-school on-premise systems. So the very tools we're using for convenience and scale are also making us way more vulnerable. So I know the situation seems pretty dire, but this isn't a story about inevitable failure. Let's talk about the solution. We're going to look at how we can fight back by building a digital fortress, a kind of intelligent defense system that's designed to protect innovation. The key here is a defense-in-depth strategy. Right? You don't just build one big wall and hope for the best. No, you build layers. You start with a really strong perimeter. Then you break up your internal network so an intruder can't just wander around freely. After that, you secure the applications. You encrypt the data. And maybe most importantly, you have a final layer of constant monitoring, always watching for any signs of trouble. But building this fortress isn't simple. It's really about making smart trade-offs. The data shows that simple things, like multi-factor authentication, are quick, they're cheap, and they're super effective. On the other hand, the absolute gold standard, a zero-trust architecture, where basically no one is trusted by default, well, that's a massive project. It's expensive and takes a long time, but it also gives you the absolute best level of security. But the fight doesn't just end once the fortress is up. Not even close. This is an ongoing arms race. As our defenses get stronger, you can bet the attackers are getting smarter. So let's take a look at the next battlefield. I mean, just look at this timeline. It shows you exactly how fast this threat is evolving. A few years ago, we were worried about pretty basic data poisoning. Now we're dealing with incredibly complex backdoor attacks and sabotage that targets the entire software supply chain. The pace of change here is just accelerating like crazy. And looking even further down the road, we've got some really game-changing threats on the horizon. The source report specifically calls out quantum-enhanced cryptanalysis. This is the idea that future quantum computers will be so powerful they can basically shatter the encryption that protects almost all of our digital information today. To really get a sense of the scale of this threat, just consider this: an encryption key that would take one of today's supercomputers millions of years to break could potentially be cracked by a quantum computer in a matter of hours. That would make almost all of our current defenses for AI models and data totally useless. So after all that, what's the bottom line? Well, this is a complex multi-front war, and right now in most organizations, the attackers are winning. They're blending different methods together to more than double their chances of success. And all the while, some of our most effective defensive tools are being critically underutilized. The threat is real, and that gap is only getting wider. Which really leaves us with one final and, I think, absolutely critical question. As we race to build what could be the most powerful technology in human history, we have to stop and ask ourselves, are we building our greatest tool, or are we accidentally engineering our greatest vulnerability? And honestly, the answer to that really depends on whether we choose to fight this secret war or just ignore it.